Let's take a look at finding the gradient at a point. This is the second part. Now, quite often we have to do this without drawing the graph. Now, in the calculus exams for NCEA 2, for the last 10 years in a row, you've always had the very, very first question asking you to find the gradient at a certain point. Each case, and I'm actually looking at all the questions right now, I've got them in front of me. In each case, they give you the x value, which they want to find, where they want to find the x value of the point, and they give you the function. So let's have a look at how this is done, and we'll talk through a bit more detail in a moment. All right. So usually they give a cubic or something more complicated, but let's have a look, and you'll see just how easily this plays out. So let's imagine you've got, and by the way, they could give it in the form of f of x or g of x, or they could say y equals, I'm going to use g of x just for a bit of variety here. G of x, by the way, it doesn't matter what this is called. It could be h of x, j of x, k of x. It could be anything you like. It's just we do tend to use certain letters for certain things later on, but you'll get the idea. So let's imagine I've got 4x to the 3 minus 2x to the 2 minus, let's go 5x plus 6. There we go. So there is our function. I'm not going to attempt to draw it. I'm going to leave it the way it is. And let's find the gradient. The question is find the gradient. I'm making this up, by the way. Gradient when x is 1. Make life nice and easy, yeah? So let's go ahead and do that. So the first job is we've got our graph, and I'm not going to attempt to draw it, as I say, but the important thing here is if we have a look at the calculus questions for the last 10 years, all of the last 10 years, they don't give you the graph. You have to be able to do it conceptually. You have to be able to do it theoretically without being able to see the graph. So this is where you have to conceptualize how this will play out. So let's do that. So here's our g of x. So I'm going to find the differential of that, because while this is the equation for the function, we want to find the gradient function. In other words, if I was to put an x value in here, we'd find y, or g of x. But if I put an x in to the gradient function, we'll find the gradient at that point in this function or on that function. So let's go ahead and do that. So I'm going to differentiate it. So step 1 is to differentiate. So I'll put step 1, differentiate. And again, if you're not quite sure how to differentiate, go back over the previous set of videos and PDFs where I show you how to do that. So step 1, differentiate the function. So in each case, we're going to state the function. So I'm going to rewrite it. I'm going to say g of x is equal to 4x cubed minus 2x squared minus 5x plus 6. And I always restate it because I'm about to do a whole bunch of stuff to it. And I always like to see what the original was first, which is here. So let's do that. So g prime of x is equal to, well, 4 times 3 is 12. 3 minus 1 is 2. 2 times negative 2 is negative 4. 2 minus 1 is 1. This has to be a 1. Well, 1 times negative 5 is negative 5. And the x falls away because it's now to the power of 0, which is just 1. And negative 5 times 1 is 5. And of course, the negative 6 falls away. So here now is our function. I'm going to restate that now. So g dash x, or if you like, m, is 12x squared minus 4x minus 5. So now we want to find that's not the graph. That's the function for the gradient. So now what we're going to do is we're going to substitute in the value of x equals 1. We're going to take that x equals 1, and we're going to bung that straight into the value here and into the value over here. Let's do that now. So the m value, or the gradient, and by the way, we could actually write this g of 1. In fact, let's do that. Let's do that. But I think they'll probably prefer you to actually do that. So we're actually finding g dash 1 is equal to 12 times 1 squared minus 4 times 1 minus 5. That's what they'd like you to do. All right. So let's go ahead and do that. That is equal to, well, 1 squared is 1 times 12 is 12. Negative 4 times 1 is negative 4 minus 5. All right. So I've got 12 minus 9. 12 minus 9 is equal to 3. So this means, therefore, we can say the gradient is 3 when x equals 1 for, I'm going to write out g of x is equal to, in fact, I'm going to write this underneath because this is very, very messy, yeah? But for g of x equals 4x cubed minus 2x minus 5x, sorry, 2x squared, minus 5x plus 6. And that's what we've found. So, going through that again, we've got a function. We want to find out what the gradient will be in that function when x is 1. So this is going to be some sort of a cubic. In other words, it's going to look something like one of those, yeah? We want to find when x is 1, what would it be? Well, let's imagine x is 1 here, for example. And that's the gradient there. So let's call that 1, just for argument's sake, yeah? So, it says step 1, we're going to differentiate. I didn't write the steps out, did I? Step 1 is to differentiate. Bang, there it is. Step 2, here is step 2. And this is to substitute. Sub x is 1, yeah? Sub x equals 1, and there it is. So now we've got x is 1, 1, and 1. Solve all this, and we end up with g of negative 1, or if you like m, we could write, is equal to 3. So the gradient is 3 when x is 1 for the function blah.